Hi, this is Spectre, and I'm here showing off my idea for what I think is a novel analog pinball plunger solution. It's based on this type of a component, which is an LVDT, which is a linear variable differential transformer. Basically, it's a metal rod that embeds three coils in it, a coil in the left half, one in the right half, and then one that goes basically the full length of it, and a metallic core. As you can see, the rod is hollow through the center, and it allows the core to move back and forth within. Sorry, it allows the core to move back and forth within the metallic rod. And basically, what this does is it allows either the primary coil to either selectively couple more with the left coil or the right coil. These are used mostly in industrial equipment to measure fairly precisely the location linearly of generally a piece of manufacturing equipment. So this core, which I don't know if you can see it too well on the video here, has a threaded center to it, can be mounted to whatever it is that you're trying to measure, in this case the pinball plunger. And based on where it is within this core, you can read out a differential voltage, which very accurately determines where the thing is. So I'm going to go show this mounted to the pinball plunger, and hopefully you can see how it works. Okay, here we have what might be the slowest fabricated pinball cabinet in the world, but it's coming together slowly but surely. What I was going to show you here is the plunger. I've got the LVDT mounted to the side of the cabinet, so it's a little different model than the one I had just shown, but it's the same basic idea. Metal rod with three coils inside of it, a left, a right, and one that runs the full length. And inside of it, which we can't see now because it's already mounted, is the movable core. The movable core is then coupled to a threaded rod, which is then coupled to the pinball plunger. So what we have now is a plunger that moves very freely. The core actually doesn't touch on the inside, so there's no movable parts to wear out. And this particular one is a DC model, which means that I supply it with DC, and it gives me a DC voltage out, which tells me where that core is inside the LVDT, which, through extension tells me where the plunger's at. So what I've got is this hooked up to a multimeter showing the voltage out, which right now is 0.6 volts in its resting position. When I pull the plunger out, it takes it up to about 4.15 volts. Leave it go back in, back to the 0.6 volts. So what you're actually seeing in that delay is my RMS meter not moving too quickly. So anyway, that's the idea. And I'll go ahead and hook up the PC and show you how it works with Visual Pinball. Okay, here we are back running the Visual Pinball default table. I have the mechanical plunger option enabled for the plunger. I'm interfacing the LVDT that we saw earlier through a USB HIDG board, which actually has an accelerometer built on board, so eventually, after I get it calibrated and installed, it will do nudge for me as well. But I've got the LVDT's output running into one of the pins of the USB HIDG device, and it is configured as the Z-axis, which is what the software is expecting for the plunger output. So with that all up and running, as I pull back on the plunger, let me see if I can get both of these in frame. Pull back a little bit, you can see the plunger moves back a little bit. It pretty much tracks exactly wherever the plunger's at. Okay, so trying to get both of these things into frame at the same time, you should see that the analog plunger in Visual Pinball tracks where I've got the actual pinball plunger pulled back to. So as I pull it back, the plunger itself moves down, release it slowly, it goes right along with it. This allows me, I can just pull it back a little bit, give it a small skill shot. That didn't do much of anything. Pull it back, say halfway, let it go. We can say pull it back 3/4 of the way. And this table pretty much requires you pull it all the way back to get it shot out. Now, pulling it back the full way. And there you go. Also, with a little bit of calibration, I think I'll be able to do push shots as well, or slam shots. As you can see, it does move slightly as I push it forward, not much. The whole thing needs calibrated. It's just set up for the first time, so I don't have any type of stop gaps or anything in there, and it seems like most of the distance of this is picked up in the latter part of the pullback. But anyway, there you go. Analog plunger in Visual Pinball, homebrew. The LVDTs, you can keep your eye open on eBay. I picked this one up literally for $5. You don't see them for that too often, but less than $50 you can pick up one of these. And I'm going to put a link on the video to a project somebody did a few years ago where they actually made one of these up out of 2 soda straws from McDonald's. So that would be the ultimate homebrew, I guess. Anyway, leave any comments. Alright, somebody had asked that I actually put on a different table and show what it was I was setting. So I have up now the tutorial table that comes with Visual Pinball, and you can see I'm setting on the Enable Mechanical Plunger option. So with that set, we can play the table. Okay, give it a coin. Now comes the ball, and now we can shoot it. So, there you go. Analog plunger with the tutorial table that comes with Visual Pinball.